I've heard you talk about supersonic aircraft. You guys have done some beautiful work at SpaceX on VTOL. Clearly, Tesla is focused on electric. Have you thought about the synergies of electric and VTOL and aircraft for solving the 405 challenge?
For solving the 405 problem, well, I mean, I do think there's a
and
really...
VTOL, vertical takeoff and landing.
Right, sorry. Vertical takeoff and landing is VTOL. I do think there's a really, I think the optimal sort of air transport solution is a VTOL electric supersonic plane. And it actually works together quite well for a bunch of reasons. In particular, the higher you go, the better the more efficient the electric aircraft is. Whereas if you have a combustion aircraft, as you get higher, it tends to get worse because you have a kind of a fixed aperture and
air scoop.
Yeah, like the engine is the hole in the front of the engine is a fixed size, and so you have to pick a particular cruising altitude, and so you've got to figure out how do you get the right amount of air at sea level all the way through really high altitude. And then you've got this issue of supersonic combustion that, so you end up having to slow the air down, and it ends up being not that efficient. But an electric aircraft would just get better and better as it got higher. And then electric motors have a higher power to weight ratio than a combustion engine, so you could actually have the power to do the vertical takeoff and landing part with a fairly small motor compared to combustion. And then you could get rid of the elevator and rudder, so you don't need the rear control surfaces if you gimbal the motor.
Gotcha. So it starts to look like a pod craft, like in Oblivion or something.
Right. It's something not quite. The real trick of it is like how do you make it really long range and at least as safe as existing aircraft. Those are really the only two questions on that front, I think. But they're tricky. They're certainly tricky.
Don't underestimate those two questions.
To have a compelling aircraft, you only really need about 400 watt-hours per kilogram, provided the percentage of cell on the aircraft is high. It doesn't need to be anywhere near as high as it is on a rocket, but if it's sort of at the 70% level at 400 watt-hours per kilogram, you can do very decent range. And if you sort of move it up to the sort of mid to high 70s, you can go transcontinental, but with, not intercontinental, but sort of west coast to east coast. So you need an efficient aircraft, but that's approximately, by my calculations, the numbers you need: 400 watt-hours per kilogram, mid to high 70s cell mass fraction, which I think is an achievable number. Because aircraft have all these unnecessary things like tails and rudders and elevators, not needed. Just gimbal, gimbal the electric fan. For some weird reason, gimbling motors is normal in rockets and not in aircraft. Why not?
Okay, well, it definitely plans to get into this business because we love to see how things develop in that particular area. Certainly a very interesting domain. Do you have specific plans?
I've been sort of toying with the design for an electric supersonic vertical takeoff and landing electric aircraft for a while. I'd love to do it, but I think my mind would explode.
What are some of the ideas that excite you today? Because there are so many brilliant ideas around the world. How could you keep focused on the things you're doing instead of being distracted by so many other good ideas?
There's a lot of opportunity in electrification of cars, of aircraft, and of boats. And I think there's a particular opportunity for a supersonic vertical takeoff and landing electric jet. That's something I'd love to do at some point in the future if my time allows. Down the road, I'd love to work on something which is a vertical takeoff and landing supersonic electric jet, and leverage the what I've learned from SpaceX and from Tesla to try to make that happen. I think it's
possible to create a much better airplane. That I have a design in mind for a vertical takeoff and landing supersonic electric jet that kind of combines what I've learned at SpaceX and Tesla, because sort of SpaceX has got the aerospace side of things and Tesla's got the electric powertrain side. And I think that would be a really cool vehicle to have in the world, because you wouldn't need big runways, and you could get places fast, and be relatively quiet, and of course it would be very low cost to operate, and good for the environment and all that.
If I were to start another company in the future, which I don't think would be anytime soon, it would be to try to create an aircraft that is a supersonic vertical takeoff and landing electric jet. I think that's sort of the ultimate form of transport, with the exception of what I was mentioning earlier, which is city pairs that are really close together and have a huge amount of traffic between them. That's where the Hyperloop would win on that special case. But in the general case, it's a supersonic vertical takeoff and landing electric plane, because obviously it would have some environmental benefits being electric and be quieter. Supersonic, it would be very fast, and if you fly high enough and have the right geometry of the plane, you can make the sonic boom no louder than current planes. And then the vertical takeoff and landing part would mean that you could land much closer to your destination instead of landing at these huge airports with super long runways. And I think that would really be great. I wish somebody would do that. And so if somebody doesn't do that, maybe at some point in the future I will.
I do think that there's an interesting opportunity to create a supersonic electric vertical takeoff and landing jet. And I think that would be really great.
How far are we from that?
Well, it seems unlikely to come from Boeing or Airbus, given that they seem to be focused on very incremental improvements to the planes as opposed to radical improvements. But it could come from a startup. I mean, if I were to have another company in the future, which would not be anytime soon, I think that would be the thing to do, is to do an electric aircraft.
You want to do an electric aircraft?
Yeah, and supersonic and vertical takeoff and landing actually work well with electric.
I think there's an opportunity to create an electric jet, essentially, and I do think one could create an electric jet that is really exciting. Something that would be supersonic, vertical takeoff and landing, pure electric, and just a big leap forward. I think that's a distinct. I'm quite confident it's doable, provided that there's a rough doubling of the energy density in batteries or capacitors. Basically around the 500 watt-hours per kilogram level is where it starts to make sense.
In order to go really fast with the plane, you have to climb pretty high, because the atmosphere just looks like molasses when you're going fast. So for distances certainly under 500 miles, you spend all your time just ascending and descending, and you don't really get an opportunity to spend time at cruise. So something like the Hyperloop can complete really well in that arena, because you instantly, or almost instantly, enter a low-pressure environment. And so the tube contains a low-pressure environment that's, like the cruising altitude of, well, it's like very high altitude atmosphere, basically, and so you don't have to spend any time ascending or descending. So there's no way it would be extremely difficult for a plane to be faster than a Hyperloop for distances under 500 miles, because of that ascent-descent thing. However, once you get to long distances, then the cost of the tube starts to become a big factor, and so then I'd say it's probably the right move is to go to supersonic transport, because then you're spending a large percentage of your time at cruise, and you could probably get there faster with a supersonic aircraft.
So if your city-to-city rocket travel works, does that mean Tesla doesn't need to build an electric airplane?
Man, building an electric airplane has a lot of difficulty associated with that.
Or what about the VTOL jet?
There's a lot of difficulty associated with that. I gotta make sure, well, it takes a massive amount of effort to do any one of these things, so you can't do them all. It's not possible. Say, oh, how you allocate the resources? What's the best thing to do? Making a VTOL jet can definitely be done. Doing electric aircraft for sure. I mean, all transport will go electric except for rockets. Yeah, everything.
I guess why it seems exciting is because if Tesla's leading in energy density and battery technology, then the logical next step is like, if somebody's going to build an electric airplane, it's the company with the best, lightest, most efficient batteries, right?
Yeah, it's hard to, it's an entirely different regulatory regime. There aren't any car companies that are also aircraft companies. So why don't they just make aircraft?
Yeah, actually, it's kind of funny. There was like some conspiracy theories on Twitter because on Instagram, Tesla's category, it said automotive, and then somehow aircrafts and boats got added.
Yeah. Boats?
Like at the Cybertruck event, they changed it or
They're
something.
Or Cybertruck.
They're making a boat or an airplane.
This is like your Wikipedia.
I think it's incredibly hard to bring an aircraft to production and meet all of the regulatory requirements worldwide. It's a very difficult thing. So it's not like it's something that could just be done. We would have to not do a bunch of other things. It's not like there's like a ton of unallocated resources at Tesla and like, oh, what should we do now? It's like a constant resource starvation. So then it's like, why don't you do this other thing? Okay, well, we're starving for resources. Then what will you not do?
Well, it seems like that's what's so exciting is now that the business is kind of taken this next step, the resource like starve is kind of changing, or hopefully slowly changing.
I mean, an airplane, like maybe another car or something. It's not.
Yeah, not necessarily in airplanes, but I'm just in general. It seems like the financial help means you can spend more on R&D, you can invest more. Like
that's not how it works. It's not like if you just had more money, you could spend it effectively in R&D. But if there was a factory producing excellent engineers, that would be true. Where is this factory? It doesn't exist. So it's incredibly difficult to find the right talent, integrate them into an organization, and have it work effectively. It's not a money thing. It's just hard to find. There's just a small number of people,
More engineers?
Especially, there's just a fundamental limitation on exceptional engineers. There's just not that many.
Like an airplane. Because you have air in an airplane, it's not getting new air in.
It is.
It is?
Yes.
They have like a little hole?
Yeah, they have a pump.
Really?
Yeah.
So it gets it from the outside?
Yes.
Wow, I didn't know that.
And it's like airplanes have it easy because essentially they're pretty leaky. But
Jesus.
As long as the air pump is working at a decent speed, they have backup pumps.
Oh.
So they have like 3 pumps or 4 pumps or something, and then it exhausts through the outflow valve, and through whatever seals are not sealing quite right. Usually the door doesn't seal quite right on a plane, so there's a bit of leakage around the door, but the pumps exceed the outflow rate, and then that sets the pressure in the cabin.
Now, have you ever looked at planes and gone, I could fix this? I just don't have the time. Too busy making.
I have a design for a plane.
You do?
Yes.
A better design?
I mean, probably. I think it is. Yeah.
Who have you talked to about this?
And I've talked to friends.
Friends?
Friends and.
I'm your friend.
Girlfriends. And
you can tell me. What do you got? What's going on?
Well, I mean, the exciting thing to do would be some sort of electric vertical takeoff and landing supersonic jet of some kind.
Vertical takeoff and landing, meaning no need for a runway. Just shoot up straight in the air and then. Ooh. How would you do that? I mean, they do that on some military aircrafts, correct?
Yes.
the trick is that you have to transition to level flight, and then the thing that you would use for vertical takeoff and landing is not suitable for high-speed flight.
So you have two different systems.
Vertical takeoff and landing system. I've thought about this quite a lot. The interesting thing about an electric plane is that you want to go as high as possible, but you need a certain energy density in the battery pack, because you have to overcome gravitational potential energy. Once you've overcome gravitational potential energy and you're at a high altitude, the energy you use in cruise is very low, and then you can recapture a large part of the gravitational potential energy on the way down. So you really don't need any kind of reserve fuel, if you will, because you have the energy of height, gravitational potential energy. This is a lot of energy. So once you can get high, the way to think about a plane is it's a force balance. So the force balance. So a plane that is not accelerating is a neutral force balance. You have the force of gravity, you have the lift force of the wings, then you've got the force of the whatever thrusting device, so the propeller or turbine or whatever it is, and you've got the resistance force of the air. Now the higher you go, the lower the air resistance is. Air density drops exponentially, but drag increases with the square. An exponential beats a square. The higher you go, the faster you will go for the same amount of energy. And at a certain altitude, you can go supersonic with less energy per mile, quite a lot less energy per mile than an aircraft at 35,000 feet, because it's just a force balance.
I'm too stupid for this conversation.
It makes sense, though.
No, I'm sure it does. Now, when you think about this new idea of designing, I mean, when you have this idea about improving planes, are you going to bring this to somebody? Or you just chuck this around?
Well, I have a lot on my plate.
Right, that's what I'm saying. I don't know how you do what you do now, but if you keep coming up with these, but it's got to be hard to pawn these off on someone else either. Hey, go do a good job with this vertical takeoff and landing system that I want to implement to regular planes. Well, listen, you're doing plenty. You don't necessarily have to get into planes right now.
Yeah.
I think you're busy enough.
Planes will be the last of the things. Cars and trucks, and then, boats, and then planes.
Well, it's interesting because plane technology in terms of like commercial air travel has probably increased, at least visibly, to the consumer the least in the last like 30, 40, 50 years. It's not much difference. The experience.
Yeah.
Pretty similar.
Yep, in fact, it got slower. So
right after the Concorde.
Not even the Concorde. Like the 747 was the fastest plane.
Oh, really?
Yeah, had a swept wings. Like so the wing sweep. Like, what's the wing angle? That's a big factor in like what its cruise speed is going to be. So the 747 had a pretty steep wing, but its fuel efficiency is not as good as something like 777 or 787. I mean, there's some like basic things in physics that are present almost everywhere. They sometimes take different form, but they're basically referring to the relationship between momentum and kinetic energy. Kinetic energy goes as a square, momentum is linear, and then there's surface to volume ratio. Surface volume ratio and the momentum to kinetic energy ratio drive so much of mechanics. It's insane. It's like the reason that you don't have like a single-celled creature that is gigantic is because of surface to volume ratio. Like there's a certain surface to volume ratio where diffusion works, and beyond that, diffusion does not work, and you have to have a circulatory system. For aircraft, or just generally, you want to move a large mass of air slowly, so you can reduce the the velocity component of kinetic energy, which grows as the square. You want to move a large amount of mass slowly, not a small amount of mass fast. So the way you make aircraft engines more efficient is you move a lot of air slowly, like big fans, basically. Big, slow fans work great. Small, tiny, fast-moving jets are very inefficient. So we're like something like 777, it's really just a propeller in a shroud. Yeah, high bypass, it's called bypass ratio. Like how much of it is jet versus propeller. You want it to be mostly propeller.
So this is clearly something you've been thinking about a lot.
Oh, sure. Yeah, like for 13 years.
Do you think it's going to be the next thing for you?
I hope not. I hope not. There's some smart people out there trying to tackle it, and I hope they are successful. But it's just try to get high. Get high.
Go fast.
Get high. You will automatically go fast as you go higher. It's just air density is dropping exponentially. And you think of like in the limit, you got like a satellite. Satellites going around the Earth, low Earth orbit satellites going around the Earth 25 times the speed of sound. No propulsion. It's not so. If you get high enough, you just keep going. Obviously, you just want to go super high. Higher the better. Now the thing, like you say, well, why don't planes do that already? Well, so if you got a combustion engine, it's got an aperture issue. So you're like, okay, how big is the hole in which you are ingesting air? And then bear in mind, air is mostly nitrogen, not oxygen. So you got a lot more chaff than you got wheat. And that's why, it's like you're going to design, this thing's got to work at sea level, it's got to work at altitude, and then it's going to drop off in efficiency quite a lot as you go higher. Otherwise, and then there's also like, well, if the air, there's some other issues relating to depressurization, like how fast can you descend, but you really just want to go super high. And it's very difficult to design a combustion engine that is effective at a wide range of altitudes. So like the air density at 100,000 feet is approximately 1% that at sea level. So how the hell do you design a combustion, like an air burning, it's like an air, there's something that's taking in air, combining with fuel and burning to work when you have 100-fold difference in air density. This is an intractable problem. But if you have an electric fan, it's not burning anything. So aperture doesn't matter. It's a big deal.
It seems like it would be the best way to fly.
Yeah.
If someone can figure out how to do it.
So I run DHL and DHL supply chain in there, and we have quite some ambitious plans towards zero emission and optimizing the supply chain of our customers to get to that. But one of the things we obviously always face is that we also run an airline, and that's actually the biggest ambition on how do we get that carbon neutral. So I'm curious to pick your brain on that one.
Well, actually, I'm just curious, how many aircraft do you have?
Many.
A lot. Okay. So aircraft will certainly go electric. The energy density requirement to have aircraft with the reasonable range is much greater than for cars or ships. So my back-of-the-envelope calculations suggest that you need about 400 watt-hours per kilogram to have aircraft with a decent range. This is with a range where it's comfortably over 1,000 kilometers, including some reserves and emergency power and that kind of thing. And then as you go above 400 watt-hours per kilogram, it gets really better in a nonlinear way because you spend so much of your energy getting to altitude. Once you get to altitude, the air is thin and your cruise power is quite low. Yeah. So once you get, if you go to like 450 watt-hours per kilogram, even though it's, well, let's say 460 or 480 watt-hours per kilogram, you will double the range. So even like a 20% increase, let's say, in energy density will double the range to at least 2,000 kilometers, if not more. So And we're getting there progressively with improvements in the energy density almost every year. So this is just watt-hours per kilogram. And a lot of the improvements in energy density actually also improve the cost because you need less material because you're able to put more energy in the same amount of material, which means less material per unit of energy. Where we are right now is a little over 300 watt-hours per kilogram, and some of the very expensive cells can do over 400 watt-hours per kilogram. But the high-volume cells, I think, will start to approach 400 watt-hours a kilogram as well. So I would expect to see a significant transition to electric aircraft, starting initially with propeller planes because they're generally more efficient per kilometer than jets, and then turboprops, and then commercial airliners and that kind of thing. That transition probably happens, I think, reasonably soon. Within the next 5 years, we should start to see electric jets.
Okay, that's fascinating.